You're on the African savanna. It's 2 million years ago. A lion just noticed you. And here's the part that should terrify you. You cannot outrun it, not even close. You cannot outrun a hyena either, or a leopard, or honestly, most of the mid-sized animals sharing this landscape with you. Your species is about to conquer the entire planet, build cities, split the atom, and put a robot on Mars. And right now, in this exact moment, you'd lose a foot race to a golden retriever. This is the story of why evolution never made humans fast. Not slow because evolution forgot about us. Not slow because we're some kind of biological failure. Slow because it turns out being fast was never actually the plan. And once you understand what evolution built instead, you'll never look at a human being jogging around the block the same way again. Let's start with the numbers because they're almost insulting. Usain Bolt, the fastest human who has ever lived, hit a top speed of about 27.8 miles per hour during his 100-meter world record. That's genuinely elite for a human. It also means a cheetah would beat him at a jog. Cheetahs top out around 65 miles per hour. A pronghorn antelope, an animal most people have never even heard of, cruises at 55. Greyhounds hit around 43. Even a dromedary camel, an animal built mostly for surviving deserts and looking unimpressed, can just about keep pace with Bolt at full sprint. In a flat-out foot race against almost anything with four legs, we lose. We lose badly. We lose in a way that should be evolutionarily embarrassing. And yet, here we are, running the place. So what happened? Why did nearly every other land mammal get some version of speed, and humans got, comparatively, a golden retriever's jog? The answer isn't that evolution skipped us. The answer is that evolution had to choose. Because speed is expensive. Building an animal that can sprint at 60 miles an hour means building an entire body around that one skill. Explosive fast twitch muscle. A flexible spine that can whip like a cheetah's. A skeleton built for short, violent bursts of power. And all of that comes at a cost. Fast twitch, sprint-ready muscle burns through energy fast and fatigues even faster. It's a Ferrari, brilliant for a few seconds, useless for anything longer, and expensive to keep running. Evolution looked at that trade-off and for humans, made a completely different bet. Here's where it gets interesting. Around 2 million years ago, something strange starts showing up in the fossil record of Homo erectus, one of our direct ancestors. Not sprinting adaptations, endurance adaptations, a long Achilles tendon that stores and releases energy like a spring with every step. An enormous gluteus maximus, the biggest muscle in the human body, which barely does anything when you walk but becomes essential the moment you run. A nuchal ligament in the back of the neck, a springy stabilizer that keeps your head steady while your legs are pounding the ground. Something gorillas and chimps simply don't have. None of these are sprinting tools. Every single one of them is a distance running tool, according to Harvard evolutionary biologist Daniel Lieberman, who has spent decades studying this. Humans were never built to be fast. We were built to go far. And this is where the story stops being about muscles and starts being about something almost nobody thinks about: breathing. If you watch a cheetah or a horse gallop, something is locked in place. Every single stride corresponds to exactly one breath. The spine flexes, the ribs compress, and air gets forced in and out like a bellows tied directly to the legs. It's mechanically efficient for short bursts, but it comes with a brutal limitation. These animals cannot control their breathing independently of their running. They breathe exactly as fast as their legs allow, nothing more. Humans broke that rule. Because we run upright on two legs, our breathing isn't chained to our stride at all. Researchers studying human locomotion, including biomechanist Dennis Bramble and physiologist David Carrier, found that human runners use all kinds of breathing patterns while running. 1 breath per stride, 1 breath per 2 strides, sometimes breathing with no fixed pattern at all. That sounds like a minor technical detail. It is not a minor technical detail. It means a human being can keep running while managing their oxygen on their own terms. A galloping animal cannot. Now add one more piece, and the whole picture snaps into focus. Sweat. Humans have somewhere between 2 and 4 million sweat glands and almost no fur covering them. That's an absurd cooling system by mammal standards. Most four-legged animals cool down primarily by panting, and panting is locked to breathing, which is locked to their stride, which means a galloping animal running at full speed on a hot day is, quite literally, cooking itself from the inside with no way to vent the heat except to stop. So here's what actually happened. Early humans figured out that if they didn't need to outsprint an antelope, they just needed to outlast it. This is called persistence hunting, and it's been documented among hunter-gatherers like the Sand People of the Kalahari Desert into modern times. A small group would identify a target, then simply keep it moving. Not chase it at full speed, just never let it fully rest. The animal sprints ahead, has to stop to pant and cool down. The humans catch up, and it has to sprint again. Over and over for hours, sometimes covering 10 or 20 miles, until the animal's body overheats to the point of collapse, while the humans, sweating, breathing freely, jogging at a pace that barely qualifies as effort, are still going. We didn't win the foot race. We won the war of attrition. Every single time, but there's a deeper trade-off buried underneath all of this, and it might be the real answer to the question. Because the other bet was the brain. A human brain burns roughly 20% of your entire body's energy at rest, despite being about 2% of your body weight. That is an enormous, greedy, metabolically expensive organ. And energy in a wild environment, it is never unlimited. Every calorie spent building explosive sprinting muscle is a calorie not available for growing and running the most complex brain on the planet. Evolution essentially had a budget, and it had to choose between an animal that could outrun a lion for 6 seconds or an animal that could outthink it, outlast it, and eventually invent the spear so it never had to outrun anything again. We know which bet won, so the next time you watch a video of a human losing a foot race to an ostrich or a house cat outsprinting an Olympic gold medalist, remember what you're actually looking at. You're not looking at a design flaw. You're looking at a 4 million-year-old trade-off written directly into your tendons, your sweat glands, your lungs, and your skull. Evolution didn't forget to make us fast. It looked at fast, decided it was a short-term solution to a long-term problem, and built something rarer instead. An animal that couldn't win a sprint against almost anything on the savannah, and somehow through sheer patience, sweat, and a genuinely inconvenient amount of thinking, ended up running the entire planet anyway.